Hi, welcome back to Why Not So Just a Tip. I'm Caleb from Timpson, and today we're going to talk about the differences between capacitive coupling and magnetic coupling. So we'll talk about capacitive coupling first. And capacitive coupling is when we have an electric field on an adjacent transmission line, say, that induces a voltage on a de-energized line. And that voltage can be in the tune of 12, 13, 1400 volts. It can be even higher, depending on the length of wire, how long they're running together, and the proximity is going to give you the voltage. We're not going to go into that calculation because it can get really, really difficult. There's a lot of variables to go into it. But the bottom line on capacitive coupling is, I'm not going to say it's not dangerous, but you can collapse that voltage field very easily by putting a ground on. And that ground usually only draws a few milliamps, 2, 3 to 12 milliamps, which would be pretty painful. Magnetic coupling is when the line, the adjacent transmission line, has a lot of current. So capacitive coupling is only going to happen on an unloaded line, a line that doesn't have much current on it. It's not being used heavily. Magnetic coupling is when we have a line that has a lot of current on it. It's heavily loaded, and maybe we're working in a hot 345 kV transmission corridor. We've got a lot of current, and that current is inducing a current on the adjacent line. That's why we sometimes call it transmission induction, or not transmission induction, but transformer induction. So if I was to draw a line and say this is my energized line, and this is my adjacent line that is dead and open. If I install a ground right here, and we imagine this earth is another conductor, what's going to happen is you have an open circuit voltage here. Because this has a heavy current induced on it, if we do this normal calculation, I times R equals E, we have a current and we put a resistance in it, we get a voltage drop. So when we have magnetic coupling, if you look here, you have very little current being drawn, maybe 20 milliamps from that one ground. Just like if we imagine a transformer, the X2 gets grounded, but it doesn't draw much current. But what happens if you ground the X1 or X3 at the same time? Well, you have an open circuit voltage there. And if you put a ground in between it, you draw a lot of current. In the terms of a transformer, you blow a fuse. Here, when you land that ground, now you've completed the circuit and you have heavy current on the line that circulates. If you remove the ground, you have a voltage between the earth and the conductor that you're going to be working on. And that's the difference between magnetic and capacitive coupling. Now, here's the tip. If you're going to work in a hot transmission corridor, it's really, really important that we have certain things like step and touch meters, because a step and touch meter is going to tell you the difference between capacitive coupling and magnetic coupling. Right? And a lot of the step and touch meters now are Bluetooth to your phone. So as the day gets hotter and maybe that line gets a little more and more loaded, and that grounded conductor becomes more dangerous, it's going to read that. That step and touch meter can read the ground current injection and the step and touch potential. And it's going to tell you that this is getting really dangerous and you should stay away from this area. If you want more information on the differences between capacitive and magnetic coupling, reach out, leave a comment, and I'll try my best to answer it. Thank you.